Okay, so I'm going to introduce Ule, who's going to be talking about building high-performance network functions in VPP.
Okay, hello. My name is Ole Trian. I'm an alcoholic. Oh, sorry, that was the wrong meeting. I'm a coder. I want to be a coder. I guess I'm a shit coder and a network engineer. So I got so inspired by the keynote this morning with all the love and the empathy. My wife has just been to this presentation course, and she told me that I had 30 seconds to grasp the attention of the audience. And it really didn't matter what you said after that. But if you didn't, you missed the first 30 seconds, you might as well just leave the stage. And you had to start with a story. So my story is that I come from proprietary software in Cisco. I've been there for 20 years. At least 15 of those working on proprietary software made me bitter and cynical and despondent, I guess. Because life there was working on, with ClearCase as your favorite source code management system. The development environment in itself was good. You got packets, everything was run to completion with pointers everywhere, and you had full access to the packet. You could do whatever you wanted to do with the packets, nice data structures and stuff. But then you had to deal with all these platforms, which was one thing, and the interfaces to the platforms. You talk about pain with NIC drivers. We could always walk over to the guy who wrote the hardware or designed it, but I didn't really make life very much easier. And then you had the other case of, you had to double commit all your code fixes to 150 different branches, and you had to run lots of sanity checking on each of those. So that would take you a month of pleasurable workday. But then I started working on VPP. So VPP is open source, something come out of Cisco, but lots of contributors now. It's on GitHub. Use Git as the SCM. Use modern tools, modern way of doing development. Don't have to talk to any product managers. Where in my previous despondent life, you would spend 7 days arguing with someone if you should write code. And now you can spend 7 days writing code and very little argument. So that's I'm very much in love with open source. I'm in love with VPP, but I think this way of working is incredibly much more efficient and much more fun. And if things aren't fun, at least I'm built that way that then I just shy away from it. Whatever much you paid, it might be a first world problem, but you get very reluctant to fix bugs if it takes you 2 years from you wrote the code until it reaches the customer. Here you can fix the bug, push the button, runs through all the CI stuff in Jenkins and Gerrit, and the code is there and available for everyone to use. So that is a lot more fun. I mean, does anyone in the room disagree with me on that? No? Anyone want to go back to the old world? I mean, we have lots of jobs there, so, So, purpose of this talk is to make you all into VPP developers. At least think about becoming contributors to VPP, or, if you want to do anything with packets, and of course you can do it on Snap as well. I mean, Snap and VPP are quite similar in their approach to life. So go in a little bit more detail on the VPP architecture and talk a little bit about a VNF written in VPP. So let me just diverge a little bit with I might provoke someone here now, but this NFV thing. It's clearly designed by someone on, having retirement homes in south of France, which is where these guys are based. It seems insanely complicated. I mean, what are they trying to achieve? So what I'm working on is somewhere sort of down here somewhere. And I'm sure there's some justification for this, possibly. but yeah, I've never figured it out. I might be, if someone buys me lots of beer this evening and try to inject some clue into me why this is really, really necessary, especially when we're talking about this decomposed network where you make these network functions into small services. I mean, there's all, in a data center, there's all, your Apache web servers have doing a few sort of REST calls. Do they have all this malarkey around them? I hope not. Although, I can see Charles who really wants, netconf and yang and models. Everything has to be modeling and, tools upon tools upon tools. So the original approach for building network functions wasn't really that. It was just take whatever hardware appliance you have, port it to an x86 platform, stuff it into a VM, and you're done. And then you can sort of do the same thing with decomposition, that you take off all the features and put those in separate VMs and declare victory. But what I'm trying to look at here is really just take that microservice, that microfunction, just a few sort of bits of packet mangling and move that on its own. So that's kind of this idea of decomposition and disaggregation. And you can do that with VPP. You can put it on bare metal or in VM or in containers or in unikernels if you like. Sort of the use cases I'm largely looking at is with service providers who need to ship quite a lot of traffic. So, last case I'm working on now is sort of building a 6 terabit CGN, like large-scale NAT. So it doesn't really make so much sense to take that VM tax or, have a virtual switch that then is going to route packets to the VMs, because you just burn cores and not providing value. So some of the models we're looking at would typically be, you could just run it on a bare metal server. Then it looks exactly like all the other products that Cisco make, right? More or less. But there are some great benefits in sort of the deployment model of containers, and you can just respin a container with a new version and have tools to orchestrate that and deploy it. So perhaps this version for that particular use case makes most sense, where we have a container bound directly to physical interfaces. And we're currently with VPP, we can build, I guess, a 4U server doing about a terabit, a little bit less than a terabit per second. And that's not fantastic, right? We're about a decade after hardware. So you can buy now a 1 RU server with 64 100 gig ports, right? 6.4 terabit per second. White box programmable with P4. So, where this is going, do you want to do everything on general purpose CPUs or not? I don't know. I mean, one benefit of competing with this is that we make, the hardware guys make their hardware a lot more programmable as well, which is cool. So what's VPP? As was said in a few earlier presentations as well, it's largely a framework for building forwarding functions. It can be a router if you want it to be a router. It can be a switch if you want it to be a switch, or it can be anything in between. Written fully in C. I think Andrew Yurchenko did a plugin in Lua, taking some ideas from the Lua guys in LuaJIT. So you could look at alternatives. It scales linearly with number of cores you put on it. Runs on ARM, x86. It's purely a data plane, so someone else should put the head on it. Although that boundary is a little bit hard to distinguish at some points. Do you put ARP inside or outside? Do you put neighbor discovery inside or outside? Where do you put your routing protocols? So you can certainly run, at home I run VPP on its own without the control plane, just the CLI and configuration. That's my CP. That works fine. We have integration with the Linux kernel, so you can pump packets to the Linux kernel to run routing protocols, for example. We can pump over tap interfaces, AF socket. We have our own shared memory interfaces you can use if you need high performance, or we can just send you packets over a Unix domain socket as well. Lots of tracing, logging, and counters, so it makes it quite easy to, after the fact, see what happened. We have full tracing of the control plane to data plane API as well, so you can replay all the commands that some controller gave you, so you can easy to debug. So VPP in a sense is an OS just without a bootloader. And I had unikernels in parentheses there. I really would like to put it on a unikernel and add that bootloader. That would make it its own OS. But it has a scheduler, it has lightweight processors. It is a fairly self-contained user LAN application. We also have a host stack with our own TCP implementation. SCTP is also coming. And the main drivers for physical hardware, they come from DPDK. But we also have AF packet, TAP, MEMIF. And I think it would make sense to put VPP on top of AF XDP as well. That would be a cool thing to have, I think. Because then you could split off control plane traffic before it hit VPP, for example. So you just left VPP with doing the data plane, and then you could split TCP port 179 from BGP, for example, off in AF XDP and send that directly to the Linux kernel. So all the highlights. This was more for the people downloading the slide afterwards. So some of the main differences in VPP versus Cisco iOS, which I used to work on, was in iOS we did scalar packet processing, which I think is what the Linux kernel does as well, which is take a single packet and run it through every feature you could imagine, from RX to TX, and you would have lots of instruction cache. We'd get lots of misses there. You'd overflow that because the number of instructions you pass on that packet would be very high. So the difference here is that you take a fairly limited set of instructions, run those on up to 256 packets. And so the first packet heats up the cache, and then you run the rest more or less for free. And that also has benefits for the data cache, because the tables you look up, you look at one particular type of table for that graph node. We have lots of data structures that are designed and optimized for packet forwarding. We don't use pointers, we use indexes, so they're dynamic arrays, which are very nice to program against. Each of these graph nodes are relatively independent, and you could sort of assemble the graph any which way you like to achieve whatever forwarding function you want. Of course, there are, you can't combine random graph functions, because that wouldn't necessarily make sense, but you can add on graphs as plugins, and you can inject or program the graph in quite a few places to add new functions. That's not me, I think. And we have pretty much all the features you'd expect from sort of a framework. We have all the tunneling mechanisms. We have V4, V6, MPLS, bridging, segment routing. We have in-band OAM, IPsec, VPN, Lisp support, lots of monitoring stuff. Very easy and quick to write new functions for VPP. And these are all written from scratch. I mean, earlier today we had some argument about, how much do you want to care about your legacy code? And in some cases, it is nice to just write things again from scratch, because you tend to become better. You rarely get things right for the first time you implement something, and perhaps on the fourth time you implement ARP, you got it reasonably right. So I at least I'm not too worried about, you provide a nice, new, and different and better programming environment, and then implement things from scratch, carrying things with you, legacy things with you, aren't necessarily a great thing. So I think you had some of this with Jerome, which is, I hate people doing, oh my God. A few people who do these things with slides should have a, they could be in the sort of entertainment industry or something. They don't have to be in engineering. But this kind of says it all. I mean, we have an RX point here. DPDK input, for example, spins around poles, gets 256 packets in the frame, sends that to depending, if it's hardware offload, hardware on the Ethernet type, it will just send it directly to IP6 input. Otherwise, it goes to Ethernet input, and it splits off here depending on what E2 type you have, and it sort of trickles through this graph. Checksum is already done by the NIC, and then it goes to V4 lookup, and you can do, rewrite, or you can do load balancing in case you have, multiple adjacencies going to the same destination in the field. So you'll end up, with most of the frame are going more or less the same path, because what we've seen in real traffic is that, the next packet pretty much looks, are quite likely to look like the one you're dealing with now. Blah, blah, blah. So I was thinking I should show you one network function that we built on top of VPP. This is a very, very simple one. I don't know if anyone knows about, so I'm also in the IETF, and we've done lots of work on V4 to V6 transition mechanisms. And this is one of these, how can you make V4 live forever mechanisms, which tunnels V4 over V6, but it splits the V4 address. So if this is a service provider and it has, 1,000, you can take one single V4 address and split it among 1,000 customers. And each customer then gets 64 ports of UDP and TCP space. No other transport protocol works. Well, if you're so stupid that you can't use V6, well, that's what you get. Well, so that's a fun thing now with you have all these people who refuse to move to V6, and they think that V4 will just continue to work the way it's always worked, but no, absolutely not. I mean, we're day by day making V4 work worse, and you just have to learn to live with that. So we're seriously thinking about one of the issues with these tunneling things, which I'm sure you guys have experienced as well, is fragmentation. And we have a draft coming up at the London IETF now in March, which would basically say, well, don't do fragmentation because it sucks. And then throw your fragments away anyway. So, which makes you learn. People learn, application developers learn very quickly. When you throw all their packets away, then they sort of try something else. But this is essentially, a V6 only access network. V4 packet comes in here. You look at the destination address and the port. You do either an algorithmic mapping or a table lookup. Figure out what the V6 destination address is. Send it here, and then this runs a traditional NAT44. And the graphs nodes for that are represented here. So you get Ethernet input. You do a bit more, V4 checking of the packet. We use the V4 lookup table to find the particular mapping table to use. Do the mapping, which generates a V6 packet, do V6 rewrite, and ship the packet back out again. And really, looking at this as a micro function, you can skip a lots of things, right? Because this packet just loops around. It goes into your graph and comes back out again. There's same interface, or there's no complicated routing function you need to do here. This is just a bump in a wire. So this is a few hundred lines of code, 150 lines of code or something, and for a particular project we did, I'm sure the control plane was 1 million lines of code, so which doesn't necessarily make too much sense. But as you see, the only complexity here is what to do with fragmentation. Because a fragmented packet, you don't see the TCP header, and you can't do routing here unless you see layer 4 information. So you have to do virtual reassembly, and you have to deal with fragments. Let me see. So I thought I, for fun, should just show you the code. So this is, oh. This one? No? That one? No? That one? No? That one? Yes. So this is the main graph function. I can do that. I have a Mac. I can do anything. Oh my God. Is that big enough? Yeah. So here I get a frame, and n left from tells me how packets there are in the frame. Then I spin through an outer loop through all those packets. And I have one inner loop here where I spin through 2 packets at a time. So it's quite simple. I have, few buffer pointers, few indexes to buffers, some v4 header and v6 header information, and some port. These are TCP or UDP ports. And then next tells me where do I expect these packets to go next in the graph. So they go to the v6 lookup. Then to keep the memory hierarchy busy, so now I'm processing, in this loop I'm processing packet 0 and 1. But while I'm doing that, I'm already prefetching information and the headers for packets 2 and 3, so they're ready the next time they come around the track. Then I will set up a few pointers here to the next frames. So these are the 2 next are the frames of, in this case, IPv6 lookup. So I just assume that things are going to go well, that I can send this to the IPv6 lookup graph node. That might fail, and then I will unwind this later. Here I just get the pointers from the buffer index. I get the headers, v4 headers for both of these two. I do a lookup in some other table I have to figure out, to get a pointer to some domain information which is specific for, which basically finds which v6 user this is. And then I find the TCP ports, decremented TTL, do lots of let's see, and then here I just do the algorithmic mapping, which is basically take U32, that's a v4 address, U16 is a TCP port. I do a little bit of bit magic or all that stuff, and I return you the first half of the resulting v6 address. And then I have a similar function to get the v6 suffix. Then I just move my buffer pointer around, slap all that information into a v6 header, or 2 v6 headers actually. So I do everything here for 2 packets at a time. And then I do a little bit of checking to see if what I expected to happen was correct. And then I validate the buffer and enqueue both of those 2 buffers. And then I go back up again. And then I have a similar loop just for the single packet. If I got 255 packets, right, there will be 1 left over. And I do the same thing for that one as 1. And that's essentially all the code required for that micro function, if you like. Right, so that's just an introduction of how VPP code can look like. Code is on GitHub. It's all open source. All we do go into that repository. And yes, any questions?
I have a question.
Yes.
Doing two at a time, so unrolling by two.
Yeah.
Is it, you really seen that is a useful thing, that speculative execution, like that's a useful thing to burn into your code? Obviously you're paying costs, it must be
So actually the current
Ule,
V4...
could you repeat the question?
Oh,
please?
sorry. Yeah, so the question is, that dual loop, is it really worth it? What gains do you see for that? I mean, we do see significant gains doing dual loops, actually to the extent that we're doing quad loops in the V4 lookup node now. I certainly remember when when I got to see VPP code, I thought, gee, there must be a prettier way of writing this. Could there be, a domain-specific language, or could you somehow make this less burdensome? So the guy who invented this, Dave Baraki, has lots of Emacs skeletons to sort of give you all the outline of this. And I would always write a single packet loop first, and then when you optimized, you would go back and do the dual loop. One issue is that it's somewhat CPU specific, right? So you might not get a quad loop might be great for the latest Xeons. It might not be the same on a different platform. So I get your point, right? It would be a lot an improvement if this could be a lot more flexible, and you could even dynamically adjust this, right? If you or at least generate code in a better way. Yeah. If nothing else, thank you.